Okay, we've got some very large numbers here, and we're being asked to find the lowest common multiple. The idea of writing down your multiples of this is ridiculous because they're going to be massive. So we need a better method, and that's going to be product of prime factors, which we've already been given. So here goes. I'm going to write down that 270. I'm going to do it like that. The way I tend to teach it in class. It's going to be 3 times 3 times 3. Okay, and then I'm going to deal with the other number, 177147. And that's going to be 3 times 3 times 3. And then I'm going to have another 8 threes. And do you know what? I'm not going to write them out. I'm just going to write it as 3 to the power of 8. And then that's that number done, but I still need to times the 270 by 2 and 5. And to find the lowest common multiple, you then circle the ones where you have these common factors, and then the rest are multiplied together. So the LCM is going to be 3 times 3 times 3 times 3 to the 8 times 2 times 5, which in power notation is going to be 2. I'm going to write they didn't write the 2 first there, which I find a little bit strange because normally write the lower number first, but it doesn't matter really either way. 2 times 3 to the 11 times 5. And what I see, okay, I like to explain why I've done this. Why have I only just times by the 3's, not 6 times here, but just 3 times? Well, I can see that 270 goes into this number because 270 goes into this. And meanwhile, 177,147 goes into this part. So I can see that both numbers go into it. However, I can also see that I can't get any numbers out. I need all of these numbers. It's absolutely essential. But times it by an extra 3 is just not essential. It would give me a common multiple, but not the lowest common multiple. Now, you could do this method quicker by just basically recognizing that, yes, I've got 3 to the 3 shared, so it's going to be 3 to the 11 times 2 times 5. That's okay as well. I like to do it. I like to write it down really carefully. You can also use the Venn diagram method. I just want to talk about this briefly. So you would put 3 to the 11. Sorry, let me try this again. Make it a little bit larger. Okay, so you could put 3 to the 3 in the middle because it's shared. Then put 3 to the 8 one side for the larger number, and 2 and 5 there. And then you'd see again that you multiply the outside, all the factors together. That could also give you the answer. Right, we're asked to give the answer as an ordinary number, so that's just going to mean I just need to put it into my calculator. And there we have it. That makes sense, doesn't it? I literally am just timesing it by 10. Actually, I forgot about that. So it's going to be 177,147 times 10, and I just shift things along the place value table. Okay, that's going to be really useful actually for this second question. Write it as a product of its prime factors. Well, I'm going to have 177,147 times and then that's 10. That is going to be 1,000,000. That will give me that 100,000. No, sorry, it's a million. It's 177,147 million. I didn't quite say the number correctly, but that's what it is, and that's going to give me 10 to the 6. 177,147 times 10 to the 6. Well, I have that this is 3 to the 11, and I have that 10 to the 6 is actually going to be 2 times 5 to the 6, because I've split 10 into its prime factors, and I'm nearly there. It's going to be 3 to the 11 times, and then I can expand this out. It actually becomes 2 to the 6 times 5 to the 6th. And that will be my answer. So very difficult question to do from scratch, but because we have the partial information and we have knowledge about 10, it's not quite so bad. Finally, this is definitely an awkward indices question, quite different to the ones you tend to see. We're asked to find the value of n in this situation. Okay, well, I can write down the above, the thing on the right hand side, as 3 to the 11 times 9 to the 5. That's going to be my starting point. Now I need to get 9 in terms of 3. I can do that because I can write 9 as 3 squared. So it actually becomes 3 squared to the power 5. And then I can use the rule that a to the n to the m is actually equal to a to the n m. So in this case it becomes 3 to the 11 times 3 to the 10. And I'm nearly there. That is I can add the powers. I'm going to get 3 to the 21. It's actually asked me for the value of n, not the value of the whole thing. So n is simply going to equal 21.